All right, with chapter 5, lesson 5, we're going to be solving linear inequalities. So we were talking about systems of equations, and now we're kind of switching to inequalities. So today what we're going to do is we're going to graph and solve linear inequalities with two variables. Okay, that's our objective for today. So whenever we're thinking about a linear inequality, it's really similar to a linear equation, but the equal sign is replaced with an inequality symbol. A solution of a linear inequality is an ordered pair that makes the inequality true. So that within the first example, what we're going to be doing is we're going to be looking at a variety of different solutions to linear inequalities and really learning how to determine a solution of a linear inequality. So let's get started with example 1. And it's actually pretty easy. I think this is, you guys are just going to get this pretty quickly. Example 1, identifying solutions of inequalities. And I remember that you guys did this back, well, no, you didn't, but that's okay. So this, you're going to be able to do this. So tell whether the ordered pair is a solution of the inequality. So we have our inequality here. This is just our x, this is our y, and you just substitute them in. So y is the same thing as 4, so you have 4 is less than 2 times x is negative 2, and you got to put that in parentheses, plus 1. And then you just do the order of operations. We can't really simplify this side of the inequality. But 2 times a negative 2 would be negative 4 plus 1. And we just work our way down. Negative 4 plus 1 is negative 3. And so is 4 less than negative 3? And that is not true, right? Negative 3 is not bigger than 4, so this is false, which means negative 2, 4 is not a solution of y less than 2x plus 1. So it's not a solution. All right? So pretty easy. You just have an ordered pair. You stick it in there. If you end up with a false statement, that means it's not a solution. If you end up with a true statement, then that means it is a solution. So let's look at the next one, 1b. So it says, tell whether the ordered pair is a solution of the inequality. No problem. This is my x, this is my y. I'm just going to substitute those values in. Y is 1 is greater than x is 3 minus 4. And then we just solve. 3 minus 4 ends up being negative 1. Is 1 greater than negative 1? Yes, 1's greater. So this is a true statement, which means yes, this ordered pair, 3, 1, is a solution of the inequality y is greater than x minus 4. So that's pretty much it. I know that you guys can do this. All right, let's move on to the next page. And this is a check it out, right? So this is really going to give you an opportunity to try to do this on your own. So there's A and there's B. Tell whether the ordered pair is a solution of the inequality. So here's my friend the pause dragon reminding you it's time to pause your device, work out A and B. When you get done, press play and we will discuss it. All right, see you in a bit. All right, we're back. Let's go ahead and see how you did. So we're going to figure out if this point is a solution to this inequality. So this is my x, this is my y. I'm just going to substitute those values in. And ooh, this one's interesting. 4 plus 1 is 5. Now is 5 less than 5? No, 5 is the same as 5. So this is actually a false, which means it's 4, 5 is not a solution of the inequality right there. So if you got that one right, awesome, awesome. Let's go ahead and look at this one. So what do we have? We have our ordered pair here. This is our x, our y. We're trying to figure out if it's a solution to this inequality, so we just substitute those values in. And 1 minus 7 is negative 6. Is 1 greater than negative 6? Yes, that's a true statement. So that means 1 is a solution to the inequality y is greater than x minus 7. So if you got that one right, yokurenkimashita, you did a great job. And we'll see you in a little bit for example 2.